Hello and welcome to HCI 509, Research Methods and Statistical Analysis. In this lecture, Lecture 16, we'll talk about some other non-parametric tests. Before we do, let's review the parametric assumptions. To do a parametric analysis, we have to meet the following four assumptions. The first is normality. We want to make sure that the data in each group should be normally distributed. The second is equal variance. So we want to make sure that the variance is approximately equal. Now, it's not going to be exactly equal in most cases, but we can see if the variance around the mean is approximately equivalent. So the shape of that normal curve or the bell should be approximately the same. The third is independence. So data in each group should be randomly and independently sampled from the population. We talked about the importance of random sampling early in this course. And the fourth one, which we didn't mention earlier, but I think it needs to be stated, is we shouldn't have any outliers. And what I mean by outliers are values that are extreme. So for example, if we're comparing the time it takes to perform a task, and the average is roughly 100, and we have 100 participants, we have somebody who completes the task in 1 second, or we have somebody who takes 3 hours or 4 hours. Well, clearly they're outliers, and that's going to affect our ability to do a parametric test. Let's talk about 4 non-parametric tests that are fairly common and can be done when we can't meet those assumptions. So the 4 most common ones are the Mann-Whitney U, the Wilcoxon signed rank, the Kruskal-Wallis, and the Friedman. And each has a slightly different context depending on the number of test conditions we're trying to evaluate and the experimental design. So when do we use each one? Well, let's start with the Mann-Whitney. If we have 2 independent samples and the parametric assumptions are met, we can use the independent samples t-test, which we talked about quite a few lectures ago. But when we can't meet those 4 assumptions we just talked about, then the Mann-Whitney U test is appropriate. If we collect data from 2 sets of the same user group, notice the design we have between group and within group. This would be with the within group studies design. And the parametric analysis assumptions are met, we can use paired samples. But when we can't meet those assumptions, we'd use the Wilcoxon signed rank test. If we have 3 or more sets of data and the samples are independent and the parametric analysis assumptions cannot be met, we would use the Kruskal-Wallis one-way ANOVA by ranks test. This is an extension of the Mann-Whitney test, which is the first test we described. If we have 3 or more sets of data and the samples are dependent and the parametric analysis assumptions can't be met, then we would use the Friedman's two-way ANOVA. If you look at the chart, you can see how these neatly form a 2x2 contingency table. First, let's talk about the Mann-Whitney U. Here's an example. We have a study that's evaluating 2 different authentication techniques, the traditional alphanumeric password and an image-based password. We have 2 groups of participants. So what is that? Is that a between group or a within group? Between group, right? And each group uses 1 authentication technique to complete a number of login tasks. And then they're asked to answer a questionnaire at the end of the study, rating the level of frustration when using each authentication techniques on a 7-point Likert scale, with 1 being the least frustrated and 7 the most frustrated. So what type of measurement is that? Is that nominal, ordinal, interval, or ratio? I'll let you answer that. Once we do this measurement, we find the mean score for the alphanumeric password is 3.88. And for the image-based password, it's 5.5. So we want to determine whether there's a statistically significant difference between the 2. And we use a non-parametric test to compare these two groups. Since we got two independent groups of participants, we use the Mann-Whitney U-test. And the results include what we call a U-value, and then we have a Z-score. And with this, we get a corresponding p-value. The Z-score is a normalized score calculated based on that U-value. Typically, you're going to see a Z referring to something that's been normalized. It has a set range between 0 and 1. So this allows us to look almost at a percentile of each of the U-values. Z-score is used with a lot of other types of statistics. And here it's a general sense to give us a normalized score. So with this example, we get a U, which is 10.5, and this gives us a p-value of less than 0.05. So this data suggests there is a significant difference in the level of perceived frustration between the two authentication techniques, and therefore we would reject our null hypothesis. And we can also conclude that participants experienced a significantly higher level of frustration when using the image-based password compared to the alphanumeric password. In JASP, we would do the following. We would go to t-tests, then to classical, not the Bayesian, and then we would go to independent samples t-test. When we run it, you can see we have our variables once we load our CSV file. And you can see with the test, we use the Mann-Whitney test. You can see we have the Welch test also, and we have the student t-test, which is the one that we use with parametric. You can see that we also say that the alternative hypothesis, remember we have two different ways to look at that, right? One of them says the groups are different. The other one says that one group is greater than the other group or less than the other group. And then we also want to look at the descriptives, because the descriptives give us the mean, the standard deviation, and something called the standard error. With this, we can see over to the right the results that we would get. So the p-value is 0.023, which is less than 0.05, and therefore we would reject the null hypothesis. Next, we move to the Wilcoxon signed rank test. So let's say we have a study investigating the use of two authentication techniques, but this time it's for people with Down syndrome. It's really challenging to recruit participants in, for example, a local area that have a special condition. And so therefore we can only come up with 10 participants. So we have a really small sample size, and we're going to use a within group instead of a between group design here. So our participants complete the study using both authentication techniques and answer a questionnaire after interacting with each. Keep in mind, we have to randomly assign which of the two techniques they use first. The mean score for the alphanumeric password is 3.9 and 4.9 for the image-based password. We need to determine if the difference is significant, and we use the Wilcoxon signed rank test for this. Since we collected it from one group of participants, we would use that Wilcoxon signed rank test, and the result of the test is a normalized z-score. So the z value we would get is minus 1.31, and our p-value would be 0.19. So it's greater than the 0.05 that we normally would assign as our alpha. And because of this, we cannot reject the null hypothesis. And we say there's no significant difference in the perceived level of frustration between the two techniques with this group. In JASP, we would go to t-test, classical. Instead of independent samples, we go to paired samples t-test. And you can see here the test I have is the Wilcoxon signed rank test. And then you can see the alt hypothesis is that the two measures are not equal. And then we want the descriptives. And over on the side, you can see that we get a W score, which is our Wilcoxon value of 12. And this gives us a p-value that's greater than what our minimum threshold is, which is 0.05. Now we turn our attention to the Kruskal-Wallis test. Let's use the following example. Now we have a study evaluating 3 authentication techniques: alphanumeric password, an image-based password, and now a drawing-based password, which I'm assuming is something like on your phone where you have the 9 dots and you draw a special pattern. So we recruit 3 groups of participants, with each group using only one authentication technique. And then we collect it from independent samples, right? Because each one's only using a single technique. So we measure the frustration rating on the same scale using the Kruskal-Wallis one-way ANOVA by ranks. So here we have our data. You can see the group is broken into 3 different categories, and we have our participants, and they give their rating. We have our coding, which refers to which group is assigned, and we come up with the following means. With alphanumeric, we get 3.25. Image-based, we get 4.63. And with this drawing-based password, we get 5.63. And we want to see if the differences are significant between these 3 techniques. Because we collected from 3 independent samples, we can use the Kruskal-Wallis method. And we get an H value. I know there's so many different letters involved, but this one, Kruskal-Wallis, uses an H. So we get H2, because we have 2 degrees of freedom, equals 11.897. And this gives us a p-value of less than 0.05. So we can make the conclusion that there is a significant difference in the perceived level of frustration between the 3 authentication techniques, and therefore we would reject our null hypothesis. So if we wanted to use this within JASP, we would go to ANOVA, classical, and then we would choose ANOVA. And you can see the results over to the right. So to do this, we need to open the non-parametrics tab. So the non-parametrics tab is down below in JASP. And then you would use the Kruskal-Wallis test, and then you would use coding to break it into different groups. The 4th test we'll talk about here is the Friedman. The Friedman is one that uses 3 groups and a within-group study, if you remember. So let's go back to the study using the 3 authentication techniques, but this time we're using, as our participants, people with Down syndrome. So we use a within-group design, and we require each participant to complete all 3 tasks using all 3 authentication methods. And then we can use Friedman's 2-way ANOVA test to do this. If we do this, we get the following 3 scores as our means. Alphanumeric, we get 3.6. Image, we get 4. And drawing-based passwords, we get 4.6. And we're trying to see if these differences are indeed significant. Using the Friedman's ANOVA test, we get an H value. And we get H with 2 degrees of freedom is 2.722. And our p-value is 0.256, so it's quite high, and therefore we cannot reject the null hypothesis. We have to say, as our conclusion, that there is no significant difference in the perceived level of frustration between these 3 techniques. To use this with JASP, we would go to ANOVA, classical, and then repeated measures ANOVA. I have a video here that shows how to do the test in JASP, and I've also put this in Blackboard. But you can see here over to the right, we get our values. It's a little bit more tricky to do this method than it is to do the other 3 that we talked about. And that's why there's a supplemental video to go through the steps one by one. Thank you very much. I will also put out a link to a web page that talks more about these types of tests. It's always a challenge to know which statistical test to use for a given situation. And I hope that this lecture has given you some insight into that, as well as the link that I'll provide. Non-parametric tests and parametric tests are both used, and they both have their place. So thank you, and I will see you next time.